Heavy metal in wastewater can have harmful effect on water body, the environment, and public health. Treatment technology like chemical precipitation, adsorption, membrane filtration, electrochemical method, and nanotechnology are expensive and accurate high construction. Subsurface contacted wetland, low-cost green technologies have been used for micropollutant removal. This study demonstrated that influent recirculation can help remove micropollutant in subsurface flow wetland by reducing influent concentration and providing additional contact between contaminant plant media and microbial biofilm. The combined influent recirculation alternative media approach facilitates metal removal in contracted wetland.
Okay, for the material method, we have 5 methods. The first one is wetland configuration. 2 pilot scale hybrid wetland system, which is the system 1 and system 2. The system consists of a horizontal flow unit HF and a vertical flow wetland VF. The system is constructed using PVC pipe and steel planes of varying height and diameter. Number 2, media and plantation. The experiment wetland used brick and sand as the main media, with cocoa pie as the organic material. Pie salt and cocoa bleach will be used for the first stage VF wetland A1 and A2, while sand was used for the HS wetland. The main median is 2.29 meter deep with cobblestone stone for efficient distribution. Paramite and vetiver species are planted and left for 10 weeks for growth. Number 3 is leachate dosing. Leachate dosing is collected from the solid waste collected and transported to the experimental site for dosing. The system was stabilized by dosing pilot waste wetland with accumulated leachate for 60 days. The loading process is divided into two periods. In phase 1, leachate was dosed twice daily to the first stage of the hybrid system without recirculation. The final output is generated by channeling the effluent to a second stage HF wetland. In phase 2, 50% of total effluent generated from the previous cycle was combined with raw leachate, resulting in an average effluent flow rate. For the number 4 is labeling analysis. The study collected wastewater from our wetland unit to examine environmental factors such as pH, dissolved oxygen, and metals. A spectrometer is used to measure dissolved metals. Plants were collected, prepped, and oven dried with a detection limit of 0.004 mg per kg of higher. Okay, and for the last one is removal affection, biosaturation factor, and transaction factor. Okay, the study calculates the removal effective of heavy metal in VF and HF wetland using equation. This study described the variation of metal concentration between UG and AG part of plant species using translation factor and biosaturation factor. Metal flow slowly from water to roof tissue and UG to AG biomass when BF and TF value are less than 1.
Base figure 1 is about influent and effluent concentration for profile of environmental parameter across VF and HF wetland. The pH range of the influent across VF wetland during 50% influent regulation period phase 2 was 7.9 to 8.3. The pH range of the influent was 7.6, 8.2 and 7.7, 8.9 for VF wetland, A1 and A2. 7.3, 7.5 and 7.6 and 7.7 for HF wetland B1 and B2. In VF wetland is effect of DO range from 2.4 to 3.7 mg per liter for VF wetland A1 and A2. The range of influent DO was 1.4, 6.4 and 2.2 and 7.1 mg per liter. For HF wetland B1 and B2 it was 1.4 and 6.1 and 4.1, 7.7 mg per liter. Base figure 2, the mean removal rate of ZNCR, NI and PB for two hybrid system A1, B1 and A2, B2, both with and without influent recirculation are displayed in figure 3. The hybrid system for vertical flow A1 and A2 unit remove matter at high rate during the no recirculation period as opposite to the recirculation period when compared to the removal profile of the vertical flow wetland. The horizontal flow wetland B1 and B2 had low matter removal rate over the course of the experimental trial. For both horizontal flow wetland, removal rate during the no recirculation period were higher than those during the recirculation period.
Next is the result of correlation between removal. This is two graphs for effluent and influent matter removal. According to figure 5, it shows the correlation between effluent matter removals in vertical flow wetlands. There is a positive correlation between metals. However, in vertical flow wetlands, the metals of plumber, show the weakness trend. Figure 6 shows the correlation between metal removal concentration and corresponding removal occurred for both systems. Based on the figure 6, the trend of correlation between metal removal is increased. So it is indicating the both system removal performance improve under increased input loading.
Primary line is a concrete piece of VS wetland acclimated higher chromium, nickel and plumbum than vertical species in brick based on system. Organic content support the metal removal and with effluent circulation improvement. Thank you.